Okay, so last time we did this multiplication, 36 times 27, and it doesn't have to be 36 and 27, I just picked those at random. But if you have a two-digit multiplication, you can always do it this way. So last time we went through box by box and actually made the complete scale diagram and counted all the squares, and we got the answer. And there are four different pieces here, and you can see where they came from. But I'd like to sort of take a little bit of a shortcut and just do a kind of a simpler, quicker way. So 36 times 27, we'll chop that up at the 36 into a 30 and a 6. We'll just make a logical diagram for that, okay? Sorry, my bad. We want to draw a box. Let's say that's, okay, let's say that's 30 by 20. And then we'll have another box. I think it was green on this side. Okay, and let's just say that's 30 along there theoretically, and that's 6 along there theoretically. It's not to scale. That's the whole idea. You draw these boxes and not to scale, but they still work because it's really just reminding us of the other box, the other scale plan that we had in the previous video or earlier on. Okay, so let's write in what we've got so far. Okay. So just go down to here. Okay, so what have we got up here? We've got 30 from there to there. We're just going to call it 30. It's not actually 30, so sometimes in a scale diagram you see this sort of thing, which means that length is not to be measured on the map, but we know we've marked it as 30, so we know it's 30. And this length here is 6. Okay, so the whole length right across from there to there is 36. Okay, and likewise we're going to do the same thing vertically. We're going to go, okay, from here to say down here is 27. All right, but it's not going to be to scale, so it'll be a little bit inaccurate, but if we keep all our numbers straight, it'll work out perfectly. Okay, so that's not really to scale. That's not really to scale, but it's still logically correct. Okay, so this distance here, what's this distance there? Okay, well, it's 36 times 27, so this is going to be the 20 part. Okay, and the whole thing's going to be 27, so we need an extra box there and an extra bit there, okay? Right, so let's draw this. Okay, from here, let's, whoops, my bad. Okay, so I want to draw a box from, say, there to there. Okay, so this part is going to be 7. Excuse me. It's going to be 7, right? And draw another box for this remaining part, which is going to be 7 times 6. Okay, so that goes and finishes out. Okay, so let's make this orange. Okay, so that's from there. That's 20, and then another 7, and these are not to scale. These are not to scale. That's not to scale. I don't need to put these little squiggles in. I'm just putting them in to make it really obvious. Okay, so that along there is 30. From there all the way along to there. Okay, and then the length of this one from there to there is 6. Okay, so it's 6. The height of that orange box, that part, is 7. Okay, this one here from there to there is 20. Okay, so you can see I've labelled everything, really. I know everything about this diagram, even though it's not exactly to scale, it's still correct. So this part here, this big chunk of blue is 20 by 30. Okay, so 20 by 30. And 20 by 30 is 2 times 10 times 3 times 10. Okay, and 2 times 10 times 3 times 10 is just, we can change the order because it's just multiplication. So it's the same as 2 times 3 times 10 times 10. 10 times 10 is 100. So it's 6 times 100. So it's 600. Okay, and previous video we actually marked out the 10 blocks, and there were 6 of them. 1, 2, 3, 4, 5, 6, 100 blocks. So it all works out. So we've got the 600 part, okay, for all the blue stuff here. This one here is 6 by 20, okay, so it's all 20 by 6. 20 times 6. 6 2s are 12, so it's 120. Okay, so if we were to draw all the little squares, we've found 120 of them in that green region, 20 by 6. Okay, likewise, this here is 7 by 30. 7 times 30 equals 3 7s are 21, so it's 210. Okay, lots of different ways to break it up and count it. As per the previous video, if you count all the squares in there, in the grey in this case, it'd be 210 of them, right? 30 by 7. 7 3s are 21. This one here is 6 squares by 7 squares, even though it's not to scale, but we could draw it to scale like we did previously. But we don't need to, we just need to remember that it's 6 by 7. So 6 times 7, now we can either draw a diagram for it and figure it out, count the squares, or we can just remember that 6 7s are 42. Okay, so this is where it comes in really handy, just knowing your times tables down pat, because you can just remember them. So now we have these we've divided this complicated problem up into 4 parts. Dong, 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 dong. Write them in, and we get these 4 different parts. Let's start here, 42. So 7 times 6 is 42. The answer to life, the universe, and everything. Then we go 7 times 30, which is 7 times 30, that one. So that's 210. Okay. Then we go 20 times 6, which is 120. Okay. So we've got that part, that part, that part, and the one missing is this here, 20 by 30, 20 by 30, 20 by 30, which is a 600. Okay, it's the biggest chunk. We add them all up together, we get 2, 4, 5, 6, 7, 6, 7, 8, 9, 972. Whoops, 972, okay? All right, if you can't read my writing, I'll just, I can type it in, I suppose, or do it this way. It is 972, okay? Just if my writing's a bit hard to read. Okay, so you don't need the blue colored squares. You can just draw this on paper. You can just draw it yourself, freehand. If you have some grid paper, what I would do is, while I'm doing this, I would next to it on a bit of working paper, when I'm doing my multiplication, I would just actually draw, crazy diagram like this, even though it's pretty messy, and I would just draw in the different parts. I would go 30, 6, 20, 7, okay, atrocious writing, 20 times 30 is 600, 20 times 6 is 120, 7 3s are 21, so that's 210, 7 6s are 42, boom. So now you have all the pieces, there's nothing missing. That's why here we sort of have these combinations, 7 times 6, 7 times 3, 2 times 6, 2 times 3. This explains why you have all those different combinations. Okay, if you have 2 digits times 2 digits, you're going to have 1, 2, 3, 4 different pieces that you can add up. We've got the 600, we've got the 120, we've got the 210, we've got the 42. It's all good. So this diagram really here explains why we have all these pieces added together and why you do this complicated thing. Okay, normally there'll be a little bit of carry, but I've sort of written them vertically to give some space, and I could put some carrying there if we overflowed and that was 13 or something. I'd write the 1 there, the 3 there, or whatever. Okay, so you can see that to help you do these kind of multiplications, you just make a diagram. Okay, so it's actually pretty easy. All right, talk to you next time. Thanks for listening. Bye.